pursuit of military dominance, the United States Navy once adopted a rifle so utterly revolutionary, so dangerously experimental, that it carved its own epitaph into the very fabric of naval history. It was a weapon of unparalleled ambition, a marvel of engineering designed to be a flat-shooting, high-penetration marvel. Yet it would ultimately be known for its fragility, its logistical nightmares, and a dark legacy culminating in a catastrophic failure that could fatally wound its wielder. This is the saga of the U.S. Navy rifle model of 1895, a brief, brilliant, and ultimately tragic chapter in the evolution of firearms.
Known by a myriad of names, the Winchester Lee, the Lee Navy, or perhaps most tellingly, the U.S. government's lament, this was no ordinary service rifle. It was a straightish pull bolt action, a design concept that promised unparalleled rapidity of fire, chambered for a cartridge unlike anything the U.S. had ever fielded, a scorching 6mm smokeless round, a miniature projectile designed to scream through the air at velocities that dwarfed its contemporaries. At a lean 47 inches and just over 8 pounds, it was a sleek, modern instrument, far removed from the cumbersome black powder behemoths of yesteryear.
Its 5-round fixed-box magazine, loaded by an ingenious but finicky en-bloc clip, was a testament to its forward-thinking design. But behind this facade of innovation lay a complex web of engineering challenges, logistical headaches, and a profound struggle for the soul of American small arms procurement. To understand the audacious leap represented by the Lee Navy, one must first grasp the inventive genius and turbulent career of its namesake, James Paris Lee.
Born in Scotland in 1831, Lee was a watchmaker's son whose early life took him to Canada before he ultimately settled in Janesville, Wisconsin. A youthful accident involving birdshot left him with a lifelong limp, perhaps imbuing him with a relentless drive for precision and efficiency in mechanical design. The American Civil War provided the crucible for his burgeoning interest in firearms, leading him to establish the Lee Firearms Company and manufacture carbines for the U.S. government.
From this point, a torrent of patents flowed from his mind, each pushing the boundaries of rifle design. He was the architect behind the revolutionary detachable vertical magazine, a concept that would define an era, and his turnbolt rifles, notably the Lee Metford and Lee Enfield, would become the backbone of the British Empire's infantry. These earlier successes, however, were but a prologue to his more unconventional explorations.
While his name became synonymous with manually rotated bolts, Lee's inventive spirit harbored a fascination with the elusive straight pull mechanism, a path he first tentatively explored in an 1872 Army trial with a sliding block single-shot rifle. Though that early attempt was swiftly withdrawn, the seed of the straight pull concept remained, dormant for decades, only to blossom in the early 1890s as the world clamored for faster, more potent firearms. Lee's journey was intertwined with the fate of American arms manufacturers. By 1875, he had joined
Remington & Sons, a prestigious firm, where his detachable magazine designs found early adoption, with the U.S. Navy purchasing Remington Lee rifles chambered in the venerable .4570 black powder cartridge. This relationship, however, proved precarious. Remington, caught in a desperate gamble for an Ottoman contract, was driven into bankruptcy by the ubiquitous Mauser. Its remnants were acquired by a joint venture of Winchester Repeating Arms and the formidable arms merchant Marcellus Hartley.
This corporate upheaval, while seemingly a setback, freed Lee to pursue his own vision. With the British government having adopted another of his rifles in 1888, securing him substantial royalties, Lee returned to the United States, settling in Hartford, Connecticut, a veritable hotbed of firearms innovation. Here, in 1892, he filed a series of patents that would lay the foundation for the rocking bolt-action rifle, a design that leveraged the bolt handle not just to move the bolt back and forth, but to tilt its rear into and out of engagement with a locking shoulder in the receiver.
This ingenious mechanism, coupled with a new detachable double-stack box magazine, marked his re-entry into the straight-pull arena. The timing was impeccable. The French Naval rifle, with its revolutionary smokeless powder cartridge, had sent shockwaves through the global military establishment. Every
Gentlemen, the
major
new data
power
confirms
scrambled
readiness.
to
The fleet is
adopt
prepared.
similar technology.
Excellent. What are the response
And the U.S.
projections?
Navy,
Sir,
long
simulations show
neglected
92%
Congress,
success.
was
We can
finally
deploy.
receiving an influx of funding.
This renewed attention ignited a desire for a rifle that was not merely adequate, but technologically advanced, future-proof, and specifically tailored to naval needs. Ships' decks demanded flat shooting projectiles to simplify range estimation. Raking approaching craft necessitated rapid fire, low recoil, and superior penetration against steel. Marines and landing parties, often outnumbered, required rifles that could deliver sustained fire and carry more ammunition.
The mantra was clear: a flat, fast, and deep cartridge, and if it could be light, all the better. The Navy embarked on an independent and highly ambitious quest for its ideal cartridge, a quest that would ultimately lead it down a unique and ultimately ill-fated path. In 1891, even before the Army settled on its .340 Krag, the Navy experimented with .32 caliber rifle cartridges.
This program, however, was paused but not abandoned by the Army's adoption of the Krag. After a meticulous 6-month review, the Navy unequivocally rejected the Army's .30 caliber offering. It simply wasn't flat shooting enough, nor did its penetration represent a significant enough leap over other early smokeless designs. Instead, their attention was drawn to the 5mm Mannlicher cartridge from Austria, a smaller, faster round that allowed for greater ammunition carriage, delivered milder recoil, and boasted an impressive point-blank range.
But even the Mannlicher, while intriguing, didn't quite go far enough. In the summer of 1893, the U.S. Navy established its Caliber Reduction Board, tasked with selecting the new naval smokeless cartridge. Their mandate was clear: consider ballistic properties, ignore the Army's choice as the Navy already sourced its own ammunition and saw no need for inter-service commonality, prioritize smokeless powder, and consider weight reduction, though not as a primary concern.
The board, free from the constraints of existing calibers, delved into the theoretical, analyzing data from around the world without the waste of purchasing and measuring every cartridge themselves. Their conclusion was audacious. They would pursue a cartridge that didn't yet truly exist. Based on complex equations of mass, velocity, and diameter, they settled on a 6mm diameter bullet weighing 135 grains, propelled by 35 grains of powder, likely German Treusdorf.
The theoretical muzzle velocity would be a blistering 2,400 feet per second, with chamber pressures pushing towards 50,000 psi, a stark contrast to the Krag's 42,500 psi limit. For rifling, they opted for a one-turn and 6.5-inch twist with 6 grooves, embracing the British Metford-style collegiate rifle. Even the metric designation was a revolutionary departure. Every other U.S. arms procurement had been denominated in fractions of an inch.
The Navy believed that adopting metric would reduce costs by allowing the use of foreign-built machinery without tedious conversions, and for their relatively limited production run, the resale value of such equipment could further offset expenses. The Secretary of the Navy approved this radical selection in September 1893. Winchester was immediately tasked with producing samples and, critically, 1,000 primed cases for further experimentation. By February 1894, Winchester was producing fully loaded 6mm cartridges, initially with 34 grains of rifle-like powder, later upped to 36 grains at the Navy's request.
5,000 rounds were ordered in March, initially with corrosive cupro-nickel-plated steel jackets, a flaw that would later be rectified. The muzzle velocity was indeed 2,400 feet per second, an astonishing feat for the era. These cartridges would serve as the benchmark for a series of rifle trials that would soon follow. In March 1894, the U.S. Navy issued a circular inviting small arms inventors to submit designs chambered for their new 6mm cartridge. 21 inventors responded, requesting 29 barrels.
Among the contenders were familiar names like Mauser, Hodgkins, Remington with a Lee rifle design, Lee Arms Company, also with a Lee design, and intriguingly, James Paris Lee himself. Lee found himself in a peculiar race against his own legacy, as both Remington and Lee Arms were submitting rifles based on his earlier patents. To win, he needed something truly new, and his continued refinement of the straight pull design proved his ace in the hole.
Patents filed in 1893 showcased his innovations: a refined cam lever, a critical sear and fly mechanism preventing forward movement until the breech was locked, and a system that kept the bolt sealed until the firing pin traveled forward. His initial submission in March 1893 had a 10-round end-block clip loaded from the underside and a cartridge counting lever. However, the Navy deemed the direct action of the bolt defective and the clip unimpressive.
Lee swiftly responded with a 5-shot charger system, though this too failed to captivate the Navy's interest. The formal trials, delayed by issues with barrels and ammunition delivery, finally commenced on October 1, 1894. The Caliber Reduction Board, with a few personnel changes, reconvened and laid down an exhaustive list of specifications that read like a wish list for the perfect military rifle.
Safety was paramount. Strong working parts, a well-supported breech box, a trigger that couldn't be pulled until the breech was locked, and a firing pin retracted before bolt movement. The magazine needed to be simple, resistant to fouling, and double feeds if possible. The extractor had to be robust and resist slipping, the ejector powerful, and an empty magazine clearly indicated. No magazine cutoff was desired, and rapid loading via chargers or clips was essential, though the rifle also needed to accommodate single loading.
Crucially, any clip or charger should not form an integral part of the magazine feed. The bolt needed solid bearing in the receiver, with symmetrical lugs, preferably at the front, to aid cartridge seating and primary extraction. Simplicity of design, resistance to environmental exposure, and toolless takedown were also stipulated. In essence, everything please.
The first wave of trials saw a dozen rifles evaluated, none immediately acceptable. Remington's bolt actions were strong, but their magazines were wanting. The data rifle was sluggish, prone to jamming. Initial straight pull design, mirroring his patent, lacked a firing pin locking safety, allowing the trigger to be pulled before the bolt was fully locked.
It also lacked mechanical advantage for primary extraction, and its end-block clip formed the feed lips of the magazine, a clear violation of the Navy's stated preference. The board recommended another trial in 6 months, though testing continued as improved rifles became available. In November, a rifle from George Luger, yes, that Luger, was examined.
This was a derivative of the Schlegel-Milch-Mannlicher, with a modified end-block clip that no longer formed an integral part of the magazine. Naval testers found only minor faults. The trigger could be pulled before the bolt was 100% closed, no empty magazine indication, and dismantling required a special tool. The Luger also used its own 6mm cartridge, slightly slower than the Navy's, but this was deemed fixable.
Negotiations began to produce the Luger rifle in the U.S., but the Navy soon ran into a political firestorm. The Army's adoption of the foreign-designed Krag-Jorgensen had enraged American gunmakers, leading Congress to pass a provision in its 1893-94 appropriations bill, effectively mandating that foreign-invented rifles could not be purchased until all American designs had been thoroughly tested. While not directly applicable to the Navy, the message was clear. The Luger was deprioritized, and renewed efforts were made to find an American solution.
Meanwhile, the Navy's relentless pursuit of advanced ballistics continued. In December 1894, at the Navy's request, Winchester began developing a rimless version of the 6mm cartridge, though experiments with non-brass cases failed. The bullet itself underwent a crucial transformation, shifting from a 135-grain steel-jacketed projectile to a lighter 112-grain tin copper-jacketed design, which significantly reduced barrel erosion characteristics.
The final result was a 6mm cartridge that screamed at an astonishing 2,550 feet per second, with chamber pressures held at a still high 43,000 psi, exceeding the Krag's limits. The Navy was ecstatic. The new 6mm cartridge could penetrate 23 inches of pine board, compared to just 10 inches for the old 4570. Winchester even marketed its commercial version by showcasing holes punched clean through 7/16-inch steel plate at 100 yards. This was indeed a monster cartridge.
In April 1895, the Rifle Board reconvened, focusing on improved American designs. The key contenders were Remington with a Livermore magazine, Lee Arms Company using mostly non-Lee patents, a bolt action from a man named Miles, and once again, James Paris Lee's straight pull rifle. Ultimately, Lee's design was preferred for its technical merits, though reliability concerns persisted.
The rear locking design wasn't a major issue, but the firing pin lock was still absent, allowing the trigger to be pulled before the breech was fully closed. There was no empty magazine indicator, and primary extraction potential remained a concern. Lee's handmade clips were also in short supply during trials, requiring repeated reloading, which degraded their function.
Undeterred, Lee made further improvements, returning with a firing pin lock and enhanced lugs to protect against pierced primers. Despite clip malfunctions during a 1,500-round test, attributed to their repeated reloading and light construction, the rifle's extraction proved remarkably robust, with only one failure due to a bulging case. In May 1895, the decision was made. The James Paris Lee straight pull rifle would be officially adopted as the U.S. Navy Rifle Model 1895, the nation's first clip-loading repeater and its smallest bore rifle, a distinction it held until the far later adoption of the
56mm cartridge. The Navy's initial ambitious list of desired extras, aluminum butt plates, wood or paper cleaning rods with steel cores, was largely discarded for practicality. The final design, though similar to the initial vision, would not be fully settled until late August 1895. A closer inspection of this remarkable yet troubled firearm reveals both its ingenious complexities and its inherent flaws.
The rifle's length, at 47 inches, 119 centimeters, was fairly standard for the era, but its internal mechanisms were anything but. The straightish pull action, at its heart, revolved around a rocking bolt handle. When pulled rearward, this handle, via a clever camming action, leveraged the back of the bolt body upwards, disengaging it from a locking shoulder in the receiver.
To the user, it felt almost like a straight pull, offering a significant advantage in cyclic rate over traditional turnbolt designs. The blade-style front sight, pinned onto a block, was designed to be covered by a sliding shield, an afterthought not introduced until mid-1897, requiring retrofitting. The forward barrel band, uniquely shaped, incorporated a bayonet lug reminiscent of a Spanish M1893 Mauser and an open stacking swivel, allowing rifles to be linked into a teepee formation.
The bayonet itself was an 8.25-inch muzzler ring knife produced by Remington, while the rifles themselves came from Winchester. The rifle featured a half-length handguard held by a lower barrel band with a standard sling swivel. The handguard itself was cleverly designed with raised sections and a slight lift off the barrel, hinting at a concern for barrel cooling under rapid fire.
Indeed, a fibrous asbestos wafer, acting as an insulator, was found beneath the handguard, a testament to the rifle's intended high-performance role. The rear sight was a standard ladder design, surprisingly low profile to prevent accidental bending, with a 300-yard battle sight and graduations extending to 2,000 yards. Its peculiar dish-shaped design required an index finger to flip it up, a somewhat fiddly operation.
Perhaps the most curious feature was a forward lower sling attachment point, a quick detach swivel integrated into a hole in the stock. This, along with a forward hook in the stacking swivel, allowed the entire sling to be held tense under the forend for compact storage, a concept seemingly copied from the Luger rifle. Such forward hooks are exceedingly rare today, hinting at met their rapid abandonment in service.
The stock itself was a nicely contoured semi-pistol grip with a deeply curved butt plate concealing a trapdoor for a pull-through cleaning kit. Disassembling the bolt revealed a complex ecosystem of parts. The bolt body, with its rear locking shoulder, was actuated by a camming handle. The striker and firing pin, driven by a coil spring and shroud, were part of an intricate assembly.
A gas vent escape hole was added to the top of the bolt during production, a crucial modification to protect the shooter from escaping gases. The extractor, a floating design, was a source of constant trouble. Early versions with a small lug riding in a receiver groove were prone to breakage, leading to later patterns that were wider and thicker.
The bolt release, a tension spring that pushed down to allow bolt removal, was a source of collector anxiety due to the grinding against the receiver. This later pattern, curling over the receiver, was an improvement over the earlier proud square-cut version that was easily knocked out of position. The rapid loading clips were equally unusual. An end-block design, it consisted of an outer sheet metal shell and an internal oblong wire. When the wire loop was flush, cartridges were locked.
Insertion into the magazine, however, forced the loop off the clip's back, rotating the wire and releasing tension. Theoretically, the clip would then fall free, but often residual tension or the lightness of the clip meant it lingered until a few rounds were fired or the rifle shaken. Critically, the Lee Navy lacked traditional feed lips.
Instead,
the
the topmost cartridge was retained by the floating instructor, which, when the bolt was withdrawn, sprung over the magazine, halting the cartridge in place for feeding. This system allowed for loose rounds to be loaded into the magazine, bypassing the clip entirely, a small mercy in a complex design. The inner workings of the action were a ballet of complex shapes. The sear, an unusually long S-shaped arm, contacted the lowest part of the striker.
In the workshop, the bolt-action rifle was meticulously assembled.
Pivoted a catch towards a lug inside the cam lever. This intricate interlock meant the bolt couldn't be opened unless the sear dropped, either by pulling the trigger after firing or depressing the bolt release lever. Upon firing, the firing pin's forward travel became a fulcrum for the sear fly, allowing it to disengage the cam lever as the trigger was released, enabling the action to be opened.
This
The rifle's
clever
design
system
harnesses
prevented the
inertia
action
for a
from
smoother,
opening
more
under
reliable
inertia,
action.
a crucial
Gas from the
safety
fired
feature for a
round cycles
high-pressure
the bow
rifle.
without it ready.
The manual safety, a vertical sliding block engaging a lug on the striker, would, when raised, drive the striker back, freeing it from the sear and preventing firing. When lowered, the striker would rest back on the sear, ready to fire. It was an ambitious symphony of mechanical interdependencies, elegant in theory, but often frustrating in practice.
With the rifle selected, the U.S. Navy turned to manufacturing. In August 1895, a circular for bids was sent out, drawing only 3 responses: the Burgess Gun Company, Remington Arms, and Winchester Repeating Arms. Curiously, Winchester, normally not known for underbidding, secured the contract at $17.60 per rifle for 10,000 units.
This unexpected
Lee's
outcome
design
may
to
have been the
Winchester's
wedge that broke up the
contract, the
Winchester-Hartley
rifle's
co-ownership
journey
of Remington, with Hartley reportedly
Engineers
feeling Winchester
refinement
had
of
unfairly
bolt and
undercut
gas
Remington's bid.
by
James Pierce Lee received $20,000 from the Navy for his design, with Winchester making a separate, undisclosed deal for commercial rights. Deliveries were set for 10 months, with a penalty of $100 per day for delays.
Crucially, the government contract indemnified Winchester from patent infringement lawsuits, a provision that would prove significant years later. During production, the Lee rifle underwent further refinements, largely thanks to Winchester engineer William Mason. However, despite these improvements, initial deliveries in October 1896 quickly ran into problems. By December 28th, deliveries were halted by Inspector Nathan.
Twining due to an excessive number of cases splitting during testing. While some issues were traced to UMC ammunition, a more alarming flaw was revealed. If a case failed, hot gas invariably wounded the shooter's eyes, albeit minorly. The design, with its raceway for the extractor lugs, left a critical gap when the bolt was slightly open, channeling gas directly towards the shooter.
The solution was a gas shield, a curved piece of metal added to the bolt body to cover the scab. New production incorporated it integrally, but existing rifles had to be retrofitted with pinned and brazed shields, a process complicated by ships already at sea and poor record keeping. It's suspected this critical modification wasn't fully completed until February 1898.
As these fixes were underway, more problems mounted. The first contract rifles were delivered by May 1897, but a month later, a fire at the New York Navy Yard exposed 2,801 rifles to saltwater, causing widespread rust. Many required extensive cleaning or overhauling, with 230 deemed unserviceable. This led to poorly documented small replacement orders, with new inspector markings like WBW, William B. Brown.
Wittily appearing on later contract rifles. Further issues plagued the design. The bolt handle had a tendency to jar out of the bolt body when sharply withdrawn, requiring early examples to be refitted. The notorious extractor springs broke with alarming frequency. Over 800 were replaced during a single campaign.
To address this, Winchester modified the extractor, making its head wider and recommending a hardened screw in the receiver for the spring to bear against, adding more power. A groove was also added to the top of the bolt body, improving side acquisition without compromising bolt retention. The manual safety proved to be another critical flaw. It had a false position, a halfway point where it held the firing pin but didn't disengage it from the sear.
A sailor, pulling the trigger to test if the safety was engaged, might find the gun wouldn't fire, but the firing pin would stage against the safety. Flipping the safety off would then cause an unexpected discharge, a phenomenon made worse by the safety's proud, easily snagged projection. The Navy even considered abandoning the manual safety entirely, but Winchester proposed modifications, a detent position with a roller on the safety, matching a modified firing pin lug.
This prevented the safety from resting in the dangerous halfway point, effectively eliminating the blammo hazard. Around the same time, reports emerged of bolts hitting the deck during drills. The original bolt stop, like the safety, was too simple and protruded proudly, making it vulnerable to accidental disengagement, allowing the bolt, and often the extractor, to escape.
During field operations in September 1897, the USS Massachusetts, with 256 Lee rifles aboard, lost 8 bolts, 22 extractors, and 28 springs. Winchester was tasked with redesigning the bolt stop, resulting in the rigid, curled-over design seen on later models, snapping firmly into place and requiring lateral force to depress. These replacements were ordered at 35 cents each, along with 10,000 new roller-style firing pin locks.
With the rifle mostly buttoned down, the Navy assessed its actual needs. Their estimated requirement was for 14,000 rifles, but they had only contracted for 10,000. A new bid for 5,000 rifles was issued, but only Winchester responded. The price, $18.75 per rifle, was actually a discount, given that the first batch had crept up to $20.04 with extras. Winchester even tried to sell them an improved commercial extractor, but the Navy, weary of confusion, declined.
This second contract was signed in February 1897, with rifles delivered between August and September 1898, serial numbers ranging from 15,000 to 20,000. This 5,000 unit gap from the first contract accounted for commercial sales, replacement of lost arms, and smaller orders. The second contract rifles arrived late for the Navy's first true trial by fire.
On February 15, 1898, the USS Maine exploded in Havana Harbor, an event that ignited public sentiment and led to the Spanish-American War, lasting from April to August 1898. Lee rifles were aboard the Maine, later recovered and sold as surplus. The war saw Marines and sailors deployed, often equipped with the unusual straight-pull rifle. But despite its cutting-edge design, too few rifles were available to equip everyone. The Commandant of the Marine Corps had requested 2,600 new rifles, receiving only 1,800 for short attachments.
Later requests for more were denied, with Marines instead armed with
whatever was aboard their attached vessel, leading to logistical chaos when units transferred.
By June 1898, the Navy had nearly 14,000 enlisted men, the Marines over 4,200, and naval militia volunteers added another 4,000. The 10,000 Lee rifles, even with the later 5,000-unit contract, simply couldn't meet wartime demands. Shortages of 6mm ammunition meant that old
4,570 rifles, including single-shot trapdoors, were still in active naval service, a logistical embarrassment in an era of rapid technological advancement. Despite these shortcomings, the Lee Navy rifle saw action and, in some respects, performed admirably. Smaller Marine contingents, often afforded the newest rifles, used them effectively in the vicinity of Guantanamo Bay, inflicting casualties at an estimated 10-to-1 ratio.
Units also fought at the Battle of Santiago and in expeditions to Guam, Puerto Rico, and the Philippines. A report from the 1st Marine Battalion's quartermaster highlighted its superior intensity, rapidity, and accuracy of fire, noting that experienced users had fewer breakages. Yet the persistent issues continued. Trigger spring failures, elevator hinge rivet failures, elevator spring sagging, frequent extractor spring breakages, over 800 replaced, shattered gas shields, distrust of the manual safety, fouling of the magazine opening, and rear sights improperly calibrated for the lighter 112-grain bullet.
Even as the second contract rifles arrived at war's end, the Lee Navy rapidly fell out of favor, not solely due to its mechanical quirks, but primarily because of the 6mm cartridge itself. Its superior ballistics were not deemed effective enough to warrant the immense logistical burden and incompatibility with the Army's 30-40 Krag. In December 1898, a joint Army-Navy-Marine Corps board recommended a uniform cartridge across all branches. The 6mm was abandoned, and the Navy, within a year, began issuing the
304 Krag, an ironic return to the round they had once proudly rejected.
By July 1900, the only Lee rifles remaining in active service were aboard ships in the Far East, excluding the Philippines. Curiously, they found their final, brief moment of glory during the Boxer Rebellion in the summer of 1900.
Marines and sailors, thrust into the anti-foreign uprising in North China, used their Lee rifles to defend the International Legation Quarter in Beijing. Expending some 20,000 rounds of 6mm ammunition, they endured repeated attacks, with foreign officials noting the Marines' effective strategies, precise fire, and high penetration in defense of the legation. It was a fitting, if fleeting, testament to the rifle's inherent capabilities, even as it was being phased out.
The Boxer Rebellion holds a unique place in history, as possibly the only conflict where 3 different James Paris Lee designed rifles saw action: the British Lee Enfield, the U.S. Lee Navy, and some Chinese contract M1882 Remington Lee rifles. The Lee Navy was fully replaced by the Krag by late 1902, which in turn was displaced by the Springfield 1903 a few years later. The 6mm cartridge, it turned out, was fundamentally unstable. As a pre-Pitzer design, it suffered from issues with its rifle-light powder, which deteriorated rapidly in the hot, humid environment of naval ship stores.
Much of the remaining ammunition was deemed unfit for service, necessitating constant replacement had the rifle remained in use. Barrel wear was also accelerated, a significant problem for a high-velocity cartridge. Commercially, the rifle and its cartridge were never a success. Its high-pressure nature demanded strong actions, limiting its adoption.
Winchester itself produced clones of the military pattern and sporting versions, but sales were sluggish. By 1913, 1,700 receivers remained in storage, eventually sold to an unknown party before World War I. A World War II memo from Winchester even lamented the Lee as the only specifically military rifle they ever produced, and on which they had lost money.
The U.S. Navy eventually surplused its Lee rifles in the early 1910s. Many sold to bannermans, who often converted them into sporting rifles for easier marketing. Winchester's troubles with the Lee Navy extended beyond sales. In 1897, Captain Andrew H. Russell filed a patent infringement lawsuit against them, presumably over the vertical magazine design. While Winchester eventually won in 1906, they had accumulated $12,000 in legal expenses.
The government, having indemnified them, initially refused reimbursement, claiming no damages since Winchester had won. After repeated failures, Winchester successfully sued the government in 1950, finally recouping their costs in 1916. As for James Paris Lee, the Lee Navy would punctuate his extraordinary list of military rifle designs, as he passed away after a lingering illness in February 1904, his inventive spirit having touched some of the most iconic firearms in history, and some of the most enigmatic.
For collectors and enthusiasts today, the Lee Navy rifle presents a unique and potentially lethal challenge. The high-pressure 6mm cartridge is notoriously difficult to reload safely. Case options are limited, and converting .304 Krag cases is precarious due to insufficient thickness at the rear. Concerns about burring or high spots on the unsupported extractor section of the chamber are rampant.
In a grim testament to these dangers, a Sarco employee was fatally wounded in 2002 by a case failure that detonated his rifle's receiver. The Lee Navy, while a fascinating piece of history, demands extreme caution and expertise for any attempt at live fire. The U.S. Navy rifle of 1895 stands as a powerful testament to an era of unbridled ambition and rapid technological flux.
It was a firearm conceived in a moment of intense innovation, designed to push the boundaries of what was possible. A sleek and potent weapon that was, in many ways, ahead of its time. Yet, its story is also a cautionary tale of the friction between visionary design and practical realities, the cost of non-standardization, the unforeseen consequences of pushing engineering to its limits, and the slow, grinding process of turning a brilliant concept into a reliably deployed military tool. It speaks to a fleeting vision of an American military, armed with unique, cutting-edge tools, ultimately yielding to the necessity of interoperability and robust, if less spectacular, designs.
What does this forgotten chapter tell us about the ceaseless human quest for a decisive edge in warfare? Is true innovation always accompanied by inherent risks and eventual obsolescence? Or can the lessons learned from audacious failures like the Lee Navy ultimately forge a more resilient path forward in military technology? The echoes of this unique rifle, with its whispers of both brilliance and danger, remind us that the future of firepower is rarely a straight line, but a winding path of bold experiments, challenging compromises, and the ever-present shadow of unintended consequences.